Isn't it just where you find one?
All right. So you have to find the z-scores for each of these. What do we know about each of these are normal curves because they're z-scores. Because it says normal distribution curve. So they're all normal. So we don't have to guess if they're normal or not. They're normal. What do we know about normal curves that would help us here? Everything under the line? Which line? The curve, yes. Everything under the curve is 1. So if I were to find area of everything, right, there's only this chart shaded. But if I was to find area of everything, it'd be 1 whole, right? Okay. What else would help us? What else would help us about this? What else do we know about it? Okay, so 68, 95, 99.7 would help us. Some of these are close, but they're not exactly those. Okay. What else do we know about normal curves? It's symmetrical, right? So this is the middle here. So everything to the right of that line is the same as the right of the other side, right? So if this is the middle 80% here, this is the middle 80%, it cuts it in half and it makes 40 and 40. So what parts, where would I start? So let's say I'm doing this guy right here. Knowing all of that stuff that you guys just said, where would I start here if I wanted to find z-scores? I would start with the left side, yeah. What would I look for on the left side? 10%, 10%, right? We know that this guy right here is 10%, or that as a decimal, right? And so is this guy here, because they're symmetrical, right? We know all that stuff. Okay, so when I go to my z-score chart, what am I looking for? The closest thing to 10%. Good. So let me get my z-score chart up here. And the closest thing to 10% is going to be on the left side. The closest thing to 10% is probably this guy right here.
1.28.
Yeah.
Okay, I got it right.
Okay.
You put the negative. Yeah, I did.
Okay.
And then
So if I venture back, that's negative 1.28. Okay. So which box is that going to be, the left or the right? The left side. Okay. So how in the world do I get the right side?
well, if it's symmetrical, just
If it's symmetrical, it's going to be the same distance from 0, right? Done. Okay.
Oh.
Now, does anyone want to change what they have so far? All right. So what about okay. So now we're going to use the box below. 80%. We're going to use the box below. 80%, right? So what we're going to put is for 80% confidence level. We're going to talk about that today. What was the z-score? Both positive and negative, right? We always use the positive for this guy here. I'll tell you what the critical value means, but this is extremely important because we're going to use this a lot today and this whole chapter and really the rest of the semester. Okay, that's where it comes from, though. Okay, so 90%, similar to 80, except a bigger proportion is in the middle. So what percent is here, and what percent is here? 5% here.
And then he just said the
5% here, right? So we do it the same way, and we get a negative. What do I get? 1.64. Let's see. Or equal distance. Let's see. Oh yeah, right here. So you got one right here and one right here. So it doesn't matter because they're both equal distant. 1.64, 1.65. Doesn't matter. Let's say 1.64. I think the actual number is right in between them. So 1.645 is probably the actual number, but our chart only goes 2 spaces. Okay. So we go down here, and for 90%, we got 1.645. Okay, so we're working our way up. Now for 95%. For 95%, what part is in here and here? There you go. So we go on our tables, which one's closest to that?
Negative 1.96.
1.96. Negative 1.96, positive 1.96.
Did you get it so down? Oh, I'm on the wrong decimal point.
Okay. So for 95%, 1.96. Okay. Now we have 98%, almost 100%. So what percent is going to be out here in the tails? 0.0100. Okay. So if we go to the tables, which one are we going to get?
Almost 2 point something.
Negative 2.33. Where am I at? Yep, right there. Yep, that's the closest one. Negative 2.33. So let's put that in there. Negative 2.33 and then positive 2.33. Good. So for 98%. Okay. And then the last one on this chart, 99%. So not even a full percent in here on each side. So which one is closest to that? 5.7? Let's see.
Yeah. Or 5.75.
Yeah, it's kind of in between again, right? So 2.575. Okay. So let's go there. 2.575. Yep. Okay, so that, which we took about 15-20 minutes to do, is in the long run going to help us out tremendously because we don't have to go and look up all of these numbers. Okay, we're going to have to utilize those quite a bit. Okay, so you see down here on the second one, the table where it says confidence level and Z critical value. I haven't explained what those are. Okay, and I will. So before we do that though, let me make a more clear example. Okay, so I have a jar of pennies here. Jar of pennies here. Let me turn it around so you can see the jar of pennies. Okay. How many are in the jar? How many do you think are in the jar? Look at it for about 10 seconds and form an opinion. How many do you think? So if you're in class, you can see it. If you're not, it kind of looks like what the picture is on you're looking at right now. How many pennies? Take a quick 10 seconds to look at it and just guesstimate. How many pennies do you think are on there or in there?
10?
Yes. I was gonna say that too. More than one.
I'm not good at this. I don't know. What'd you say, John?
Greater than 0, less than 5,000.
Oh. I don't know. There's like 3.
I'll give 300.
You go 300.
I'll
I'll
give
go
you
like 4. 3.
That way.
3.
Okay, so let's write down some numbers. Let's write down some of these numbers. Okay, so
I don't know.
guesstimates. What do we get? What do we got here?
300.
300. One.
All right.
What's another one?
316.
316.
Or 285?
285 is another one.
What did you say? 285.
Okay, anybody else?
Well,
Greater than or equal to
1.
1?
That's it? Nobody else has any. No one else thinks anything differently. 390.
How heavy is that?
Okay.
That's a good point.
All right. Okay. So
I'll put it on
my question isn't so much how many pennies are in the jar, because a lot of you guys were like, "Oh, it's between this and that." My goal, my question to you then is your number that you had in your head. How can I make you become more confident in your guess?
If I counted it. You just count.
Then it wouldn't be a guess.
Oh,
Okay. How can I make it more confident in your guess?
I want to know the weight of a penny. And I want to know the weight of that jar.
I want to know, yeah, the weight of what, the weight of each penny, the weight of the jar, and then the weight of the jar by itself.
Can we get the volume of the jar?
Yeah, I'm gonna need some numbers.
I don't think that would honestly. I don't think that would help you at all. But what some of you actually said it earlier. Some of you actually said it. How can I become more confident in my guess?
I would need some more numbers.
What did some of you say earlier about it? No, because weight wouldn't help you guys. Because if I told you the weight of one penny, that wouldn't help you.
And then you get the weight of the jar. Right? You guesstimate the weight of the jar.
Okay. But then you have the weight of the plastic.
Right. So you would weigh the jar by itself.
And if I told you all those numbers, I'm giving you the answer. That's not a guess anymore. Okay.
Somebody said it.
So if it's just based off a guess, how could I get you guys to be more confident in your guess?
Yeah, I don't know if anybody said it.
A couple people said what
What does start with?
I would. What's that?
What does start with? Magical word.
What's that?
What's the
I don't know. You guys said it.
Wait, I heard it. I
What did you say, the computer? Armin, what did you guys say? Come on now.
It wasn't. It was the ones that like to talk a lot. They were the ones who said it.
Oh, man.
Oh.
Keep going. Keep going. Keep going. Keep going. Keep going. No, he just said it right now. He just said it. He just said it right now. Keep going. What?
Oh, so it's in between, so like a greater than, less than.
There you go. Right. Right. Some of you guys said greater than 1 and less than 5,000. Okay.
Let's go.
Or greater than 1 and less than whatever. Right.
Well, it's definitely greater than one.
Right.
Really?
Yeah.
Wouldn't that be a bigger help if I were to give you like an interval?
Yeah, sure.
Wouldn't that give you more confidence than if I actually gave you the weight of this thing? Right? Because I mean, each penny is probably different. Because each penny, there's oxidation on some of these pennies. Some of these pennies are older, so the weight might be different. And you're talking millimeters of a millimeter of a gram or whatever. So if I gave you just like a interval, like if I said the interval could be 100 pennies wide. So instead of 390 or 300, you could say between 200 and 300. Would your confidence go up or would your confidence go down? Slightly, right?
More chance of me.
What if I said your interval could be 200 pennies wide? So between 200 and 400 or 300 and 500, would your confidence go up or would your confidence go down? Right? So as the interval gets wider and wider, what's happening to your confidence? It goes up right there, right? It goes up. Eventually till you get to a number where you're like, I'm darn near 100% confident that that's the correct answer. Okay? Guys, let's knock off the silly part because this is extremely important. Okay? How can I be more confident in my guess? What did we just say?
You have to have a large interval.
Okay? The larger the interval, what?
Higher.
The higher the confidence, right? So eventually it gets to a point where you're almost 100%. You can't be 100% confident, right? You can't be 100% confident, but you can get pretty close to that, right? I'm 99% confident that the true number of pennies is between this number and this number, right? Because the numbers you guys giving me, how can you not be 100% confident? Because the number you guys giving me are not even close. Not even close. So even if I gave you a leeway of 500 pennies and you guys said, oh, between 200 and 700, that's not even close. That's not even close. So that's why you can't be 100% confident, right? You can never be 100% confident. But you could, your confidence level could go up, right? So for me to raise my level of confidence and my guess, I would need, what would you need? What would you need? What would you need? Does it say, please tell me the answer, Mr. Flores? No, it has a line, right? What do we do on lines? We fill it in. So fill it in. Fill it in. What would you need me to do based off our conversation we just had to be more confident in your guess? The answer is not in your phone, it's in your head. So you don't need your phones, you don't need the calculator. What do you need? Okay? Finish the sentence. Okay, for me to raise my level of confidence in my guess, I would need what? An interval, right? Just an interval, yeah. An interval for me to feel the bigger you get of an interval. Like I said, you could have an interval of 200, 300, 400, 500, 600. Eventually it'd get to a spot where you're like, I'm pretty much 100% confident that it's between there, right? That right there is the definition of what we call confidence intervals. Confidence intervals. We get to an interval, right, where you're confident. So what we're going to talk about, and the first problem we're going to do here, we might get to the first problem at that, but it's answering that question. It's answering that question. You're predicting what's in there, okay? But for different questions. How confident are you? The bigger the interval, because this is the question, I guarantee you'll be on the test that we take. It'll say, how do I raise my confidence level? How do I raise my confidence level? A, B, C, D, E. How do I raise my confidence level? What do I have to do to raise my confidence level? The interval gets larger. The larger the interval, the larger the more confident you're going to be. Okay? Okay. That's the definition of, like I said, what a confidence interval is. We're trying to predict what the true answer is. You're trying to predict how many pennies are in this thing. Okay? To do that, to take a shot in the dark and say 482, you're not very confident. That's just a shot in the dark. But if I said, okay, you get an interval of 100 between, so you can go from 100. So, okay, so 400 to 500, 600 to 700. I'm a little more confident. Okay, intervals of 200 pennies. A little more confident, and slowly and surely you get more and more confident. That's the definition of a confidence interval. Okay? So, what we're going to decide, we're going to start today are intervals for proportions. Confidence intervals for proportions. That's what we're going to focus on today. Okay? Z. Have we seen any Z-scores today?
Yes.
That's why the Z is there, right? The Z is there because those Z-scores that you did in the very beginning are going to come important when we actually have to do a confidence interval. Okay? That's why we did the hard work then. So when we actually do the work, it's already done for us, or a lot of it is. And then the one sample is based off of one sample. We only have one sample. In the question, there will only be one sample. Okay, so that's where all of those come from. One sample, Z, because we're using Z scores, confidence interval for proportions. Okay, all right, so to do a confidence interval, you need to do 5 things. 4 of them you've done before. 4 of them you've done before on the last test and last chapter. The only one you haven't done is number 5, conclusion. And you kind of have done a conclusion because you guys summarized it, right? So really, you've done all of them, okay? Step 1, identify the population parameter of interest. If it's a population, if it's a proportion, it's going to be P equals, and it's going to start true proportion of whatever you're talking about, just like you did on the test. If it's mu, it's the true mean, whatever they're talking about, right? Test statistic formula. I will give that to you. I will give that to you. It's not going to be given to you. Well, I should say that. It's hard. It is given to you, but not specifically, okay, on the test. And I'll talk about it when we start doing these. Conditions, assumptions. Oops. Those are exactly the same as you guys are used to seeing for proportions. These are proportions for proportions. Those should look familiar. That's not new. Calculations, that's not new. Conclusion, that's not new because you've done it before. Okay? So a lot of these aren't new. They're asking you a different question. They're not asking you probability now. They're asking you a different question. They're asking you to predict what the true parameter is. Okay? Given a sample. Okay? All right, so let's do the first one. Let's look at the first one. Example number 1. Example number 1. Okay, so the owner of a popular chain of restaurants wishes to know if completed dishes are being delivered to the customer's table within 1 minute of being completed by the chef. Okay, they want to know if the food is getting to the customer fast while it's still warm. It's important to them. They don't want food getting to the customer when it's cold. Okay, so what he or she does, whoever the owner is takes a random sample of 75 completed dishes that are found, and he or she found that 60 of them were actually delivered within 1 minute, the way they wanted. That means 15 of them were not. Find the 95% confidence interval for the true population proportion. So the owner can't do this. What's the word? He or she can't follow every meal, right? Why can't they do that to every meal they serve? Too many meals, right? Who's going to do that? You have to pay someone to do that, or I have to do it as the owner, if I'm the owner, right? Can't do that. So that's why they only did 75. Okay. So what they're trying to do is take those 75 and see what the true answer really is. What percent of all of the meals are getting to the customers within a minute? Okay. So they're using the sample to make conclusions based off the population. Okay. All right. So the first thing we have to do, well, the first thing I always do is list everything I know. Okay. So what are the things that I know? Okay. So a random sample of 75. So how do we write that? Not P. N equals 75. Good. It's a 95% confidence interval. Even though we haven't done confidence intervals, that's going to be important later on. Now I know I told you the answer. I told you the answer 2 slides above. It's a proportions question, right? But on test day, I'm not going to tell you if it's a proportions or if it's a means. So it's important for you to kind of look for things that will help you with that. Okay. Well, things that help you, well, here's one of them right here. It says the word proportion in the question, right? So what is our proportion? There you go. What is that? What symbol do we give that? P hat, not P. P hat is what we're trying to predict. If I already had P, Why would I do this, right? I'm trying to predict P using P hat. P hat's the sample. Why did I put 60 over 75? Okay. Anything else? We got 60, 75, 75, 95% confidence interval. That's about it. Okay. All right. So let's go to step one. Step one says identify the population parameter of interest. That's P. So we start true proportion.
True proportion of males delivered in a minute.
There you go. There you go. This is P hat. This is the sample, right? So where does this sample come from? That's what I want to know in words. Where does this sample come from? Well, this is based off of 75 meals. So 60 out of 75. So P would be every meal, right? The true proportion of all meals that reach customers within 1 minute. Okay, that's the population. That's the parameter. It's not the population. The population is all meals, all dishes. Okay, served. This is different because I'm looking. This P represents a proportion. All right, so 1 done. 2, test statistic. Test statistic is right here. It looks ugly and gnarly, but trust me, you know some of it, and the rest of it's pretty simple. I just put a lot of notes on there because they will, sometimes they refer to some of the things. Okay, so this is this guy right here.
Is that a given?
Some of it is, and technically the whole thing is, but not. It's
You're not going to give it to us on paper.
No, it's on paper.
Well, the second part is the first part.
So everything in yellow is the equation. Okay, everything in yellow is the what we're going to use, our formula. Okay, so let's break this down real quick. First thing is P hat. P hat is what we call the point estimate. That's our estimate of the answer before we do the confidence interval. P hat. So in our case, P hat is 60 out of 75. Okay. Z critical. You already know that. Why do you already know that?
Is it asking us to find it? Is it the critical score? Yeah, 0.96. 1.6.
So it's based off of what percent confidence interval? How confident do I have to be? So the Z critical we're going to use is 1.96. Okay, so let's go back. This part here, why is this part not that big of a deal? You used it already, and it's on the chart. You don't have to memorize it, right? To me, this is the hardest part to remember, but it's given to you, right? Because all you're doing is you're taking P hat, Z critical. That's not anything calculated, right? Z critical is not anything calculated. It's just from our chart. P hat comes from the question itself. This is the part you have to calculate, right? So this part right here is given to you on the test. The part I just underlined, or I'm sorry, on your sheet. If you look at the sheet, the back of the sheet, that's given to you. Isn't that technically the formula? Statistic plus or minus critical value times the standard deviation. That's technically the formula. So when students say, do I have to memorize the formula? I'm like, no, they give it to you. It's right here. But exactly, it's not specific. Okay? It works for all confidence intervals. Okay. Okay, so, oops. I actually put slides on here that would help. Okay, so let's actually fill these slides out. So let's rewrite what we have. The true proportion of all meals that reach the customer in 1 minute. Okay. And then we always have to write which formula we're going to use. So p hat plus or minus z critical times p 1 minus p over n. Why do we have to write the formula? Because that identifies what procedures we're using. That identifies we're using a one sample z confidence interval for proportions. Okay, that's why it identifies the steps that we're using. Since we didn't write that, that's why we have to do that. Okay, the next thing, assumptions. They're the same. They're the same as last chapter for proportions. Okay, so conditions, and then we have to check them. So number one, SRS. Okay, is it stated? It says stated in the question. Okay, so stated. Number two, 10% condition. N is less than or equal to 10% of big N. Well, N was 75. We said that at the beginning. We don't have a number for big N. So who would the population be? All meals delivered, yeah, all meals delivered. Okay. Since we don't have a number, we just write down who the population is and we check it and move on. The last one is normality. Since it's proportions, we say n times p has to be greater than or equal to 10. And n times 1 minus p has to be greater than or equal to 10. We don't have p. Yeah, that's a good point. We don't have p. So what are we going to use instead? Take a wild guess as to what we're going to use. P hat. All we have is p hat, so that's what we got to use. Oops. So we have n is 75. P hat was 60 over 75, so let's change that to a decimal. 0.8. Okay. So 0.8 and then 0.2 over here. So let's see. Yeah, this is going to be 15 and this is going to be 60. They're both over.
You're probably right.
Because 10% of 75 is 7.5, and if you double that, that's 15. Okay. Last step is second to last step is calculations. Calculation. So now we're going to use that formula that we had before. Okay. So we're going to say p hat. P hat is 0.8. Plus or minus. Z critical. What did we say was Z critical for this problem? Good. And then we have to use the same formula we've used before. What was it? 0.8 times 0.2 over 75 square root. That'll give us our interval.
Wait, plus or minus? Let me know.
Both.
Oh, we're always gonna use both?
It's always going to be both. So what I do in my calculator is I do this part first, and then I add 0.8, and then I subtract 0.8. When you add 0.8, it goes here. When you subtract 0.8, it goes here. So I'll do this side first in my calculator. So plus 0.8, I get 0.8905.
Wouldn't it just be that for negative?
Say what?
Wouldn't the other one just be the same thing but negative?
Second. Let's see, let me do this again. 0.8 times 0.2 divided by 75, take the square root, times 1.96, and then 0.8 minus that, I get 0.7095, round it. That's my interval. That's my confidence interval there. This is a proportions question, so it represents a proportion or a percent. So it's from about 71% to about 89%. So there's about 20% interval here, pretty wide. So the last thing, we have a fire drill coming up here in a few minutes. So we won't be able to do the conclusion, but that's the last part of it. We'll do the conclusion tomorrow. But pretty much what we're going to do is we're going to go off of this and say what this means. Conclusion is just, what does that mean? Okay? Pretty much what you're going to say is the true answer. The answer to the question is somewhere in between here. How confident are you? For this question, 95% confident. I'm 95% confident that the real answer is somewhere between there and there. That's what it's saying. Okay, and then we'll format it tomorrow because I don't want to rush this part. Okay, we did the heavy lifting. We just got to format it next. Okay, alrighty. Okay, so yep. So the bell should be ringing here about a minute or so. Once it rings,